Eric Burgess here, and we have been asked to solve for x. And so this is a question where we're going to use the order of operations to simplify it, and then we're going to get x all by itself. So first up, we should recall the order of operations. So let's recall PEMDAS. PEMDAS. Recall this happens first parentheses, then exponents, then multiplication and division from left to right, and then addition and subtraction from left to right. So let's go ahead and look at this. So first up, parentheses. So here's a set of parentheses, but this is really just for multiplying this 3 in to be distributed. So we're not going to do that one quite yet. So we've checked our parentheses. It's not really an operation inside the parentheses. That's why we don't consider it a parentheses step. It's really a multiplying step. Next up, we have exponents, and if we look here, we see we have no exponents. So now we go multiplication and division from left to right. So this 12, nothing happens to it, so we're going to keep the 12. Now over here, we have 18 divided by 3, and so 18 divided by 3, and then the x, we can just sort of put the x to the side. It's kind of like we have this, 18 divided by 3 times x. It's like the x is off to the side. So 3 goes into 18 6 times, so this would become 6x. So plus 6x. And then for the parentheses here, we have some multiplication happening. We have a 3 being distributed in to these things, right? They're being multiplied. And I highly recommend writing the lines because it kind of helps you visually see it. And so 3 times 3, that's 9x. And then 3 times negative 3 is minus 9. And then finally, we have equals minus 5. And then we have 3 times 2. Well, 3 times 2, that's 6. So that's plus 6. Excellent. So from here, we just do addition and subtraction. And recall, in this step, you can only combine like terms. So for example, this 6x and this 9x can be combined. But this 9x and this 9 cannot be combined because it's lacking in x. But the numbers 9, negative 9, and 12 can because they are like terms. So we're going to combine the 12 and the negative 9. So we have 9, 10, 11, 12, so that's 3. And so we have a positive 3 because this is a negative 9. So it's like 12 minus 9. And then we have 6 and 9. We can combine these since they both have an x. So 6 plus 9 is 15, and then we keep the x. This is equal to, and then we can combine these as well because they're just numbers. So that's like 6 minus 5. Instead of thinking of it as negative 5 plus 6, you should just think of it as 6 minus 5. It's easier. And that's 1. And we're allowed to swap the order of things. We can write 6 minus 5. It's still like this is a plus 6. But that's just a more easy way to think about it. So once we're here, all we have to do is get rid of x. Now the way we have to isolate x is we start with the stuff that's furthest away from it on the same side. So here's the side x is on. The numbers furthest away are over here. So this 3 will be the easiest thing to get rid of first. So we look at this and we say, well, this is a positive 3. If we want to move it to the other side, we'll have to do the opposite of that. So we're going to put a minus 3 on each side. So this minus 3 is going to cancel out with this positive 3. We didn't do anything to the 15x. All we did was add a minus 3 to one side. And since we added it to one side, in order to maintain the equality, we have to do it to the other side. So we add a minus 3 to the other side. Now these combine to 0, because 3 minus 3 is 0. And 1 minus 3 is negative 2. And the 15x is still here. Technically, there's a plus 0, but 15x plus 0 is just 15x. So we don't write that. And now what we have left is 15x equals negative 2. To separate the 15 from the x, what we do is we do the inverse. So since this is multiplying, we are going to divide. And if we do it to one side, to keep it equal, we have to do it to the other side. Now, what's cool about dividing by the number that's here is that it turns into 1, right? Because 15 over 15 is the same thing as 1. Any number divided by itself is 1. And 1 times x is just x. So that's a really nifty way to just isolate x. And so we say that x is equal to negative 2 over 15. And that is our answer. Now we can check our answer because this, if we pick this as our x, we're saying that if we plug this in for x up here, that this will wind up being a true statement, that they will equal each other. We already know that this side becomes 1. See, we already did that stuff. So this is all equal to 1. But when we plug in the x, is this equal to 1? That's our question, right? Because when we do 3 times 2, that was 6, like we had before. And then negative 5 plus 6, that's 1. And so now we're going to plug it in over here. So I'm going to grab my calculator. And in our calculator, in order to check it, we're just going to use this first equation. So we're going to put 12 plus, and then they have a fraction here. We could use this up here, but we did stuff and we could have made a mistake here. So we want to use the original because we didn't manipulate this at all, unless you like copy it down wrong. So we have a fraction here, and there's actually a way to type fractions. This F1 key has fractions in it. So if we push the green key and then F1, it brings up this menu, the function 1 menu, and we can type a fraction right here. So we're going to put a fraction in, and then we're going to get 18 over 3. That was a fraction. And now this 18 is being multiplied by x, right? When a number is next to a variable, that is the same thing as them being multiplied. So to do that, we put parentheses. I always recommend putting some parentheses down because that maintains the multiplication. Whenever you sub in, you can't mess up if you put parentheses. There are times when we don't need it, but it's a good habit if you're not confident with that yet. Okay, so our x is this right here, right? We're claiming that this is x. So I'm going to type a fraction. So I want the function 1 menu again to put another fraction in there. And we want negative 2. Remember, you have to use the special negative key over 15. Okay, so that's that part. And now we have plus 3 plus parentheses. Whoops, just plus 3. Then parentheses. And then it's 3 times x. So again, we put a parenthesis down. We put in our x, which is this. So we type a fraction, which is the alpha key, F1. And then we're going to put minus 2 over 15. And then we're going to close the parentheses. So this is just for replacing the x. That's all that's there for. Minus 3. And then another parenthesis to close this outer set. And that's it, because then we hit the equal sign. So we already know that this side's equal to 1. So if this side turns out to be 1, then we know that our answer is correct. And we hit enter, and we get 1. So this is evidence that we did it correctly, and we have a high degree of confidence that this is the correct answer, that we did not make a mistake. If you have any further questions about this, let me know. Feel free to stop by the online tutoring if you are a Citrus College student, and we'll catch you in the next problem.